Okay, good morning to all. Am I audible?
Yes, sir.
Okay.
Yes, sir, you are audible.
Right, so we will start. We will take a few more numerical. Mm, Yes. So in this numerical, this information is given. This is known as boom, B-O-O-M. Boom is a component of crane, and the purpose of boom is to lift heavy loads, and it is actually movable. It can move in horizontal direction as well as in the vertical direction, right? So you can consider this to be a boom, and it is of length 6 meter. At this location, which is at a distance of 2 meter from here, there is one rope, and this rope is passing over a frictionless pulley in this manner. What is actually given? This boom AB is supported in the position, that is, the complete system is in equilibrium, by a hinge at point A and a cable which runs from C. So this is point C over a small pulley at point D. So this is a frictionless pulley. Compute the tension in cable and the horizontal and vertical components of reaction at A. Neglect the weight of the boom. So what you are supposed to identify? First of all, you are supposed to identify the tension in this member, tension in this rope, and secondly, uh, the self weight or the weight of the boom is 0. It has to be neglected. Some forces are given. These are the loads which are attached at this point B, and at this point over here. This is 200 Newton. This distance is 2 meter. And again, from this point to this point, this is 2 meter. So complete distance is 6 meter. What you are supposed to identify? Tension in this cable, that is this. You can say T suffix CD, tension in rope CD, and you are supposed to identify the reactions at point A or support A. So very quickly you are supposed to draw the free body diagram. It is very simple. Once you have identified the tension force over here, what you are supposed to do, you are supposed to draw the sketch. You can even draw single line sketch. ऐसा कुछ नहीं है कि you are supposed to mention the thickness of this rod. There is no necessity, right? So what you can do, you can directly draw the necessary forces, external forces. अच्छा, one more information is given, the inclination. ठीक है? So for that, this complete distance, okay, this is 8 meter. This is 8 meter, and the slope of this boom, it is again given. This is the slope is given as 3 horizontal, 4 vertical. 3, 4. 3:4. Fine. So since the information related to the slope is given, what you can do is you can identify the theta value. Okay, so you can identify this theta. Let me call this to be theta. Then the reaction forces, whatever are there, you are supposed to assume at point A. I am assuming it to be like this, positive. So this is the free body diagram. And after drawing the free body diagram, TCD, this is 100 Newton, and this is 200 Newton. You identify this theta. Kitna hai the theta? Tan inverse of 4/3. That will be the value for theta. How much does this come out to be? 53.13. 53.13. And if this is 53.13, this will also be the same value of theta. Alternate angles. Okay? Then, now you need to be careful as far as this angle is concerned. That is, angle which is made up by this inclined force. So from the geometry, this is the small angle which you will be interested to find. Let me call this as beta. So see, actually this is straight line. Huh? Yes, straight line. Yeah, say yeah. And the distance is 8 meter. Okay. So can you please calculate this beta angle? Can you please calculate this beta angle? For that, you may require the information related to this, isn't it? So let me call this point to be point E. तो ये ऐसा triangle form होगा. One minute. This will be like this, and this is straight line. Huh? Okay. So what you have done, you have dropped a perpendicular from here to here, that is at this location, and you are supposed to identify this beta. Can you please let me know what will be the distance ED? This is point A. Like this. This is how much this complete distance will be now? 4 meter. Am I right? This will be 4 meter. This already you have evaluated this angle. Can you please tell me this distance? ED. So how much does that come out to be? 4.8 आता है क्या? Yes? 5.6. 5.6. Please check. What is this distance CE? CE. 4.52. Can you please tell me in terms of some value? Yes, sir. 2.4. Okay. CE is 2.4. Then what is AE? That is AE must be sine component. Okay. So AE, if it is 4, am I right? It will be 4 sine 53.13.
Yes, sir. 3.2.
So this is 3.2 meter. So ED shall be 8 minus 3.2,
Yes, sir. 4.8.
4.8 meter. Okay. So we have calculated this ED value, right? From here, can I not calculate the beta value? It will be very simple. Tan inverse of ED by CE. So does it come out to be 63.43? है ना? 4 tan inverse of 4.8 divided by 2.4, right? So this will be the beta value. Okay. That means while resolving this inclined force into the components, the values now shall be TCD cos of 63.43 and this shall be TCD sine of 63.43. Is this okay? ये ठीक है? Please let me know.
Yes, sir.
Now the final sketch. So I will not represent this inclined force. I will represent it in terms of the components, both the components over here, right? This is theta now. Theta we have calculated to be 53.13, 53.13 degrees. Okay. Now the remaining thing is to identify the unknown values, whatever are asked. Okay. So the unknown parameters are TCD and the reactions at A, RAH and RAV. TCD cos 63.43 sine 63.43, right? This is 100 Newton, okay, and this is 200 Newton. This is given. This is 2 meter. This distance is 2 meter. This is again 2 meter. Now, very purposefully, I have drawn these dotted lines because we will be using equations of equilibrium, and in that you will find you will take moment. You have to take moment because there are 3 unknowns. Okay? So first of all, using equations of equilibrium, summation of forces in x direction equal to 0. How many forces do you observe? 1 and 2. So RAH minus TCD cos of 63.43 equal to 0. So this will be equation 1. Next, summation of forces in y direction equated to 0. TCD sine 63.43, which is positive, minus 100 minus 200 plus RAV equal to 0. We need to take moment. Moment about point A equal to 0. By this, what we are doing? We are eliminating two unknowns. However, we have two more unknowns over here, but we need to decide upon any one point. It will be very much convenient if we take moment about point A. We can even take moment about this point C also, but the calculation may be more, or it may get complicated. Okay, equation may get complicated. So what you do, you take moment about point A. What is this force? 200 Newton. And this 200 Newton will rotate about this point A with a perpendicular distance of how much it shall be?
1 by 2.
2 cos 53.13. बराबर है?
Yes, sir.
Okay. And it is rotating in the clockwise direction. Then over here there are two forces. But what we can do, we can replace the position of these two forces at this point to this point. Or what we can do is we can make use of the perpendicular distances with respect to these two forces. So for example, TCD cos of 63.43. What now will be the perpendicular distance associated to this?
3.2.
That will be, is it 2 sine of 53.13? Am I right? Will it be the sine component?
So 4 sir, 1.
Sorry, 4. Right. Wait, 8 minutes. Yes, this will be 4 sine component. That will be 4 sine. Correct. 4 sine of 63 point, sorry, 53.13. Am I right?
Yes, sir.
And in which direction it is rotating? It is rotating in the anti-clockwise direction. So this will be negative. Then this TCD sine component, TCD sine of 63.43 into 4 cos of 53.13. बराबर है?
Yes, sir.
Then how it is rotating? It is rotating again in the anti-clockwise direction. So this will be minus. Then again plus one more force is there, that is of 100 Newton. 100 into, here it shall be now 6 cos of 53.13, and it is rotating about point A in the clockwise direction. So is this value okay?
Yes, sir.
This equation should be equated to 0. From here you will get the value for TCD. So if anyone has calculated the value, please let me know. Yes, how much is the value?
100
Yeah. Is it this value? Please verify. 167.74. I am getting this value 167.74. You can verify this value, and once you get this value, you substitute in the earlier two equations in order to get RAV and RAH. By that, I am getting RAV to be 149.97 Newton, and RAH, this value I am getting it to be 75.02 Newton, and both the values are to be positive. These both the values are positive. That means whatever I have considered, that is correct. But we need to find out the reaction at point A. These are nothing but the components which we have obtained. So in order to find out the reaction force, the reaction shall be resultant, okay, and associated theta value. So the remaining thing you can solve. You know how to calculate the resultant and the associated theta value. ठीक है? Okay. Now the next numerical. I expect everyone's attention. This is point B. 500 Newton. This is the cable whose slope is given 4 horizontal, 3 vertical. Point C, point A. Distances are given. This is from here to here, 3 meter. Then from here to here it is 1 meter. And again from here to here it is 1 meter. Right. So what is given in this numerical, I will just read out. Be careful. A pulley of 1 meter radius. That is this. This is 1 meter radius. Supporting a load of 500 Newton is mounted at point B on a horizontal beam. If the beam weighs 200 Newton, weight of beam given as 200 Newton, okay, and the pulley weighs 50 Newton, weight of pulley 50 Newton, okay. Find the forces on hinge at point C. That means you are supposed to identify RC. Reactions at C. Those may be RCH and RCV. This is given. This is the given information, and this is what you are supposed to identify. Everything, the pulley and all, it is frictionless. Just try to think. I will be back in few minutes. Okay. So how will you approach? One more information that at this point B, these two rigid bodies, that is pulley and the beam, they are connected with the help of this pin connection you can say. Okay, it is mounted at this point B with the help of smooth pin. So what do you expect in this numerical? What do you think? How many reactions do you expect at point B? Can anyone tell? If you remember, I had told you whenever there is a certain kind of connection, when two bodies are connected with the help of pin support. Okay, so equal and opposite reaction forces are transferred on the bodies, right? On the rigid bodies, those are connected with the help of that pin support. So if I separate, let's say first of all, this pulley. This is at point B. Yes.
So where is the force binding of the axis?
Uh, Come again. I didn't get you.
There is the force binding of the axis.
uh, force where
So 500 Newton को mass ही तो weight ही है.
mass of the weight of the beam. This is given 200 Newton
Okay.
and weight of the pulley is 50 Newton. Okay. So if I say some weight of the beam is given and weight of even the pulley is given. Okay, so what I will do, I will separate this pulley and I will separate the beam. Fine. I will try to draw the forces which are available on this beam firstly. So at point A and point C and even at point B, I will be drawing the necessary forces, those may be available on all these locations. So at point B, I know at point A and point C, since they are hinged connections, there will be two forces like this, RC. Okay. What do you think at point B? How many forces do you expect to be developing because of this given information? कितने फोर्स आ सकते हैं?
Only one.
One force. अच्छा. And which one? What will be the direction of that
50
force?
Newton.
What will be the direction?
Downwards.
Huh?
Downwards.
Downward. Okay. One student is saying that there will be only one reaction force which will be developed at this point B, which will be in the downward direction. How many of you agree? Or someone else has got some another thing to say? Yes? Okay, as yes, yes, yes. Okay. So as per your information, this force at point B will be acting downward. That means over here on the pulley, that same force of same magnitude will be acting in the upward direction. This is what you meant to say?
Sir, I was not talking about reaction force. I just mentioned to your question.
No, no. And I am just asking about the understanding of yours related to this problem and the given information. If you remember, now just we will try to recollect. If you remember, we have covered one numerical wherein two pulleys or two cylinders, they were attached with the help of this type of rod, and these connections were with the help of again smooth pins just like this. And in that case the self weight of the beam was 0, because of which we have also derived, because of this situation, the vertical reactions, they were 0. Why? Because the self weight was 0. If that weight had some finite value or non-zero value, then these two values would not have been 0. And similarly over here, if you see, that's why I was very much stressing on this aspect. Weight of the beam, this is 200 Newton, which is given. That means the self weight of the beam will be somewhere over here, that is at the center of the beam, and the magnitude will be 200 Newton. And because of this information, you will see the reaction forces which will be developed at this location B. In addition to the vertical, you will find horizontal force will also come into picture. Or with Vice versa. That is, in addition to the horizontal, vertical force will also come into picture. If that value was 0, then this vertical reaction would be 0. Okay. So over here in this numerical, you are supposed to take care, since this magnitude is given, magnitude of the self weight that is given. Therefore, we will have to consider the reaction forces. Those will be developed in both the directions, that is in the horizontal and vertical direction at point B. Because at point B, two rigid bodies are connected with the help of this smooth pin. Got it? Is this okay? Am I clear?
Sir,
Yes.
sir, how is the beam and the pulley connected?
At this location, you mean to say, at this
Yes,
point,
sir.
with the help of a pin support. So you can expect a hole which has been made in this pulley, and similarly a hole is made in this beam. Okay, and through that hole a pin is inserted, and that pin is then wounded with the help of nut. Okay, or it is tightened with the help of nut. Okay, is this fine?
Yes, sir. Okay, sir.
So this is how the connection is made. But while representing the free body diagram, you are supposed to be very much careful, because if I assume the direction of the reaction force to be in this way for beam, then equal and opposite direction should be represented on the other rigid body, right? So before solving for this, because you can see the number of unknowns on the beam is quite more compared to the number of unknowns on this pulley. So let us try to first of all solve for this pulley system, and then we will eventually go on to this beam, right? So for your understanding, let me draw this. आज ये पेन नहीं चल रहा है, ग्रेट. ठीक है. So this is the pulley, and over this pulley you can find that there is a weight. Okay, and over here you can expect tension force, right? Because this end of the rope, it is connected with the help of a fixed support, so tension force will be developed. Fine. This is how much? 500 Newton. So as per this free body diagram, what will be the value of this tension force over here? How much?
500 Newton.
It will be 500 Newton. Okay. And what do you expect the value of tension force over here? Everything is smooth.
Same, sir.
Same value of 500 Newton. Okay. You have got the information related to slope. So very quickly you let me know what will be sine value and what will be cos value. That is the angle, this angle. How much it should be? Is it 36.87? Please verify.
Yes, sir. Yes, sir.
36.87. Okay. And at point B, as we have discussed right now, there will be two reaction forces, those will be developed. Okay, one will be in the horizontal direction, another one will be in the vertical direction. And why? Because this beam has got self weight, and because of that you will expect a vertical reaction also, right? So let us assume, see, initially we need to assume the reaction forces direction, later on we can modify them. Okay, so this is, let me consider RBH, and let me consider this to be RBV. One more information is given with respect to the pulley, that is self weight of the pulley is 50 Newton. So it will again act like this. Okay, magnitude is 50 Newton. So over here you can see there are only two unknowns, right? And with the help of this information, or with the help of this free body diagram, we will be in a position to identify the RBH and RBV values. So can you please find out these values? So in order to find out these values, summation of force in x direction, equate them to 0. How many forces are there? RBH minus 500 cos of 36.87 equal to 0. From here I will be getting RBH value. कितना आता है RBH? 400 Newton. Okay. Similarly, summation of forces in y direction equal to 0. So RBV minus 50 plus 500 sin 36.87 equal to 0. कितना था RBV?
सर 500 भी कंसीडर करना पड़ेगा.
Yes. Yes. One more. Yeah, correct. Yes. This 500 Newton should be considered. Very good. So minus 500 equal to 0. Correct. This has to be considered. So how much does this come out to be? 250 Newton. So my assumed directions for RBH and RBV, they are okay. Once we get this information from the free body diagram of this pulley, so what we have done, we have considered the free body diagram of pulley. Okay. Now we will go to the free body diagram of the beam. So in case of the beam support, which is like this, okay, you have these two parameters over here. At point B, over here it is like this. So this is RCV, this is RCH. Okay, then there is a self weight which is of 200 Newton, right? Then what else? These values, that is the reaction forces at point B, right? This is A. This is okay. Now while considering the values at point B on beam, so this is free body diagram for beam. So as we have discussed earlier also, the reactions, whatever you have found out over here at this stage, that should be transferred in the equal and opposite direction. Magnitudes will remain the same, right? So what will be the direction? This is negative x over here, and now this value will be how much? This was 250 Newton, correct? And since it is in the upward direction, at this point B on the beam, it will be in the downward direction. What was the value of RBV? How much it was? I think it was 400. Oh, sorry, ulta likh diya. This is 250. This is 250 Newton, and this was 400 Newton, right? Okay. Now this becomes the free body diagram of the beam, right? Uh, this is how much? This complete is 5 meters, so this will be 2.5. Okay, and remaining will be the distances or remaining values. That means this will be 2 meter. This is 2 meter, and this is 0.5 meter distance. Am I right? Should I draw on the bigger scale? Should I draw the bigger figure for this?
No, sir, it is okay.
Okay, fine. So this is how much? This distance is 0.5, if I am not wrong. 0.5 meter. Okay, and this magnitude is 200 Newton. बराबर है? Now remaining thing is to calculate these values, that is RAH, RAV. We are not actually interested in finding out reaction at A. We are interested in finding out reaction at C or reactions at point C. Okay. So you calculate summation of forces in X direction equate them to 0. How many forces do you observe? So minus RCH. I am assuming this direction, right? Initially, I am assuming in this way. Minus 400 equal to 0. Therefore, RCH is equal to minus 400 Newton. That means my assumed direction is wrong. I need to modify it. Okay. Then summation of forces in Y direction equal to 0. How many forces do you observe? Oh, 1 minute. There is also one term of RAH equal to 0. 1 minute. Sorry, my mistake. This is not hinge. This is roller. This is given in the numerical. My mistake. This is roller support. So because of that, you will find only one reaction force over here, that is RA, and that's why this will be equated to 0, and RCH will be now minus 400. Okay, that was roller support, not hinge. Fine. Now summation of forces in y direction. So over here, RA minus 200 minus 250 plus RCV equal to 0. So this is one equation. So let's say equation number 2. This is 1. Now you take moment about point A itself, because we are interested in finding out C value. So that's why you can take moment about summation of moment about point A equal to 0. So very quickly, let me know. 200 into 2.5 clockwise direction. Am I right? 200 into 2.5 rotating clockwise. Then next 250 into 3 meter, again clockwise. बराबर है? 400 will pass through point A, no need. Then RCV into 5, and it is rotating in the anti-clockwise direction, equate it to 0, because RCH will again pass through point A. So from this equation, what do we get? RCV. How much do we get? Very quickly, let me know. 250 Newton. Okay. And similarly, you can even calculate RA value also. Okay? So this is how you are supposed to identify the values for uh, unknown values whenever such situation arises. That is, two rigid bodies, they are connected with the help of pin support and weight of the beam is given. In that case, you need to be careful. Self-weight, if it comes into picture, both the reactions at the pin support will be generated. Is this okay? So
Yes, sir.
RCB and RCH, you have got two values. You can identify the RC value and the theta value that you can solve. Okay?
Yes, sir.
Okay, so I will stop over here. In the next lecture, we will see few more numerical. One more thing, I have uploaded the assignment number 1 in the classroom. I hope everyone is able to see that. I have also written the instructions. You are supposed to submit the assignment number 1 by 26th. Is this okay?
Yes, sir.
ठीक.
Yes, sir.
Thank you.
Thank you, sir. Please, sir.